Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss next problem on nodal analysis. The question is find the current through 50 ohm resistor. There is 50 ohm resistor here through which we have to find the current, and we are going to again use nodal analysis. Otherwise, you could have used mesh analysis also. There are 3 meshes, but if you now pay attention to this first and the second mesh, there is a current source between the 2 meshes, and hence if you are planning to apply mesh analysis, you had to apply super mesh analysis, because mesh 1 and mesh 2 will form super mesh. Mesh 3 will give you one equation, super mesh will give you one equation, and difference between the two currents equal to 1 will be the third equation, and that's how you can solve 3 equations and go ahead. In nodal analysis, we have to first identify the nodes in the network given circuit. So this is one node, this is second node. You can see there are 3 branches connected on all these nodes, and this entire line will serve as the third node. We take this as the reference node, alright, and let me call this 2 node voltages as VA and VB. First we will find VA and VB, and then we will find current through 50 ohm resistance, which is this. So let's apply nodal analysis. I'm going to first write down KCL at node A. So applying KCL at node A. Let's see what do we get. We had said that define all the currents to be outgoing, but this time you can see that I'll define these 2 branches having outgoing currents, but there's already a current source in this vertical branch, and this current is entering at node A. So there is no point in defining it to be outgoing again. So what I'll do is I'll define this current as incoming only, because that's how the original current source is given to us. So now we will apply KCL, saying that sum of outgoing currents is equal to sum of incoming currents. Outgoing current, the very first outgoing current is through 20 ohm resistance. Because it is flowing towards left, the polarity of the voltage will be plus on the right, minus on the left. Because in whatever direction the current flows, there will be fall in voltage across the resistor. So this will be the polarities. So when I write this expression of this current, I'll have to start from VA, because that's on positive side, and then minus 60, because that's the battery available in this branch. So the first term will be VA minus 60 divided by 20. That's the resistance. So it's voltage difference upon resistance, simple Ohm's law. Second outgoing current is through 30 ohm towards right. Now towards right means the drop will be plus minus. Plus is on node A side, minus is on node B side. So it's VA minus VB upon resistance 30. And now on the other side, I'll consider incoming current. The only incoming current is equal to 1. So that comes on the other side. So this will give me, I'll take VA outside, so it's 1 by 20 plus 1 by 30, because there are 2 terms for VA, 1 by 20 here and 1 by 30 here, minus VB by 30, and this 60 by 20 will go on the right hand side, and when it goes to the right hand side, it will get added to this one. So 1 plus 60 by 20, because it was minus here. So if you simplify, you get 0.083 VA minus 0.033 VB, and this will be equal to 4. So that's my first equation in the form of VA and VB. Let's now consider second equation, which will be at node B.